Find the sum. The sum of the first n term of arithmetic sequence formula is Sn equals to n over 2 times a1 plus an. For this problem, first we have to find a1 and an. In order to do that, to find a1, we have to substitute 1 in n. So a1, negative 5 times 1 minus 2 equals to negative 7. Our an is negative 5 times 36 minus 2 equals to negative 182. As of again, the sum of the first n terms of arithmetic sequence formula is given again. Because now it's easy to substitute the term a1 and an right into the formula. Sn equals 36 divided by 2 times negative 7 plus negative 82, close parentheses. Negative 7 plus negative 182 equals to negative 189. Then we multiply 36 times negative 189, which gives us negative 6804, gets divided by 2 and gives us our final answer, negative 3402. Find the sum of the geometric sequence. The sum of the first n terms of a geometric sequence formula is Sn equals a1 parentheses 1 minus r to the power n close parentheses over 1 minus r. For this problem, we have to find a1, a2, and r, which is equal as our radius. So for a1, we substitute 1 instead of k. 1 over 5 times negative 2 to the power 0, 1 minus 1 gives us 0, equals to 1 over 5. a2, 1 over 5 times negative 2 to the power 2 minus 1, which gives us 1, equals to negative 2 over 5. To find our radius, we divide our a2 by a1. So negative 2 divided by negative 2 over 5 divided by 1 over 5. Just for the reminder, we use the rule keep, change, and flip in order to find our radius. So negative 2 over 5 times 5 over 1 gives us negative 2 as of our radius. So all we have to do is just now plug in the values in the formula we just have found. So we have as a1 1 over 5 parentheses 1 minus negative 2 to the power 13 close parentheses over 1 minus parentheses -2 close parentheses gives us 1/5 times 8193 divided by 3 gives us 546.2. The polar coordinates of a point are given. Find the rectangular coordinates of the point. So we have 7, 2 pi over 3. Our 7 is our radius and 2 pi over 3 is our theta. So for this problem, we have to convert polar coordinates to rectangular coordinates. The first step is to do is graph this. So on the x-axis we have positive 7 and 2 pi over 3 is 120 on the unit circle, and this leads our graph to second quadrant where sign is positive. So we have x equals r cosine theta. We just have to substitute 7 as of our r and cosine theta as our 2 pi over 3. So we have 7 times -1 over 2, which gives us our x value -7 over 2. To find y, we do the same exact thing as we did previously. So y equal r sine theta. We have 7 sine 2 pi over 3 equals 7 times radical 3 over 2, which gives us 7 radical 3 over 2. So our answer is -7 over 2 comma 7 radical 3 over 2. Find the following ninth term of arithmetic sequence with given terms. A7 equals to 52, A13 equals to 112. The arithmetic sequence formula is an equals a1 plus parentheses n minus 1 close parentheses d. We have to find a1, d, and an. So for a7, a1 plus 7 minus 1 equals to 60, which equals to 52. For a13 equals a1 plus 13 minus 1 gives us 12d equals to 112. So we do subtraction to the equation. a1 minus a1 cancels out. 6d minus 12d gives us -6d equals 52 minus 112 equals to -60. -60 divided by -6 give us our d, which is equal to 10. Now we find a1. We just substitute d equals to 10 in any equation. So here it is. a1 plus 60 equals to 52 minus 60 from both sides, which gives us our a1 equals to -8. For an, we just substitute in the formula. An equals an minus 1. Our d is 10, which is positive, so it's gonna be plus 10. Determine whether the infinity geometry series converges or diverges. If it converges, find the sum. So we have 32 plus 8 plus 2 plus infinity, infinity, infinity dots. So to find the sum, we have to divide the second term by the first. So 8 divided by 32 gives us 1 over 4. And the formula is, so our formula for that is S infinity equals A1 over 1 minus R. Since we have found our R, which is equal to 1 over 4, we just simply plug that in. So our first term A1 is 32 over the formula 1 minus our R is 1 over 4, which equals to 32. 4 times 1 is 4 minus 1, which gives us 3 over 4. So we simply multiply 32 times 4 over 2 gives us the answer 128 over 3.